Okay, class, this is going to be part 2 for our 70-741 lesson 2, DNS. So let's take another look in our textbook and do a little bit deeper dive into DNS. DNS we talked about previously. It's a naming service. It uses TCP/IP network. Our servers that run DNS we also call name servers. If you remember, we talked about how we communicate on an enterprise. If you're at your home and your home router gives you your IP address, it also runs DHCP. You're on a personal network, right? So how do you look up DNS information? Well, that DHCP that's provisioned by your ISP probably has an entry to their DNS server on the internet. That allows you to resolve names on the internet. But what if you've got resources in your home that you need to be able to resolve? Will the public ISP's DNS server work for that? Absolutely not. In the etc folder under Drivers, System 32 Windows in your C drive, you can find a file called hosts. It doesn't have a file extension, simply hosts. And you see a sample of that on the screen here. Anything with a pound symbol is simply a comment. However, you can see the last two lines show two 192.168.3 hosts that reside on this person or this company's network, and they have added that entry to the host file, so internally this client, this device, can find those resources. If you're going to use host file, you have to put these entries on each and every device that you're going to use. Not very efficient. DNS is much more scalable. It's easier to use. It's consistent. One change on your DNS can be migrated or replicated onto all your DNS servers so that you have uniform DNS records for lookup. Your clients look to one place. You don't have to worry about configuring a host file on a whole slew of clients. It's very time consuming. We talked about fully qualified domain names. Let's take a look at that hierarchy that we talked about. At the very top level, you've got the root domains, the .coms, the .edus, the .govs. Below that, you have your second level domains. That's where we give it names: Microsoft.com, Intel.com, Contoso.com. Within that, we can create subdomains. Server 1, www, corporate, sales. You can create an entire hierarchy within your DNS domain naming. In fact, it is called a hierarchical system. Within there, we have resource records, and that holds the information associated with the domain name. Remember our common top-level domains: .com, .org, .edu, .gov, .net, .us. These are all top-level domains. Nowadays, we also have .biz, .info, and so on and so forth. There's used to be very restricted the number of top-level domain names that are available. Today, there's many more. The host is a device that resides on that domain, and its fully qualified domain name is shown as illustrated here: computer1.sales.consoso.com. So how do we resolve those names? Because that ends up at being an IP address. We can't remember those IP addresses. I can remember some of them, but I sure can't remember them all, let alone trying to remember the IP addresses for websites. We use what's called a DNS resolver. Each one of our devices has a DNS client that it runs on that device. It has a cache of known records, known associations between IP addresses and names. If it knows a resource, it can immediately go to that resource. If it doesn't know, and it has to find out, hey, I know a name, but I don't know the IP address associated with it. It connects to your primary DNS server, and if it knows that inquiry, it responds back, and now the DNS client knows it, adds that to its own internal cache, and it's able to access the record. If it doesn't, if the primary DNS server doesn't know, the DNS client simply waits, because what happens then is the primary DNS server, it in turn contacts another DNS server looking for that information, and so on and so on. When it gets that response back, the primary DNS server adds it to its own cache for the next request. It replies back to the DNS client with that information, which in turn adds it to its own cache and then can access the resource. So this way, you could have 1,000 clients, and if they're all querying this one primary DNS server, and that DNS server knows a record, it responds back to all 1,000 and they can access it. One client accesses a new resource, or it inquires, it makes a query for an unknown resource. Once that primary DNS server has it, it's cached, and now all those 1,000 devices can access it without having to do or waiting for another lookup. Excuse me. So here we can see the process of what's called an iterative query. One, we do what's called a recursive query. It says, hey, what's the address of support.contoso.com? Well, our DNS server doesn't know. So it does an iterative query to its root server. It says, what's the address of support.contoso.com? The root server responds back with the address of the .com server, because there's a set of series of servers at those top levels that handle nothing but top level requests. Our DNS server then does an iterative query against that .com server and says, hey, what's the address of support.contoso.com? And it replies back with the address for contoso.com. Our DNS server then does another iterative query, says, hey, what's the address of support.contoso.com to the contoso.com server? And it replies back with the address of the support.contoso.com resource. Our DNS server then replies back to our device with the address of support.contoso.com, in this case being 182.13.24.56. So now our DNS server caches that record, or caches that lookup, and our device also adds that to its own internal cache, and it can access the record. We talked about the split DNS, we talked about planning. You're going to go through your reading and go through all the different requirements. You're going to go through your step-by-steps. We'll be covering this in our next lab that will accompany this lesson. And as you know, most of these are just step-by-steps. How to deploy a VHD image and host DNS in it. Very efficient use. So at this point, I'm going to allow you to continue your reading. If you have any questions, of course, send me an email. You can always contact me. My office hours are posted in D2L. My contact information is there for you as well. And we'll be moving on to Lab 2 in 70-741. Look for that video to be posted next. Thank you.